Here's another collisions example. So we have in this figure, a 3.5 gram bullet is fired horizontally at two blocks at rest on a frictionless table. The bullet passes through block 1 of mass 1.2 kilograms and embeds itself into block 2 of mass 1.8 kilograms. The blocks end up with speeds v1 is equal to 0.63 meters per second and v2 is equal to 1.4 meters per second. Neglecting the material removed from block 1 by the bullet, find the speed of the bullet as it A leaves and B enters block 1. So here, I like this problem because we have two different collisions. One is a kind of combination of elastic and inelastic. It's not completely elastic because it doesn't say it is, and the kinetic energy here would not be conserved. So we can treat it just like kind of like an elastic collision though. But number 2, the second collision, so the collision with the bullet in block 2, that is a completely inelastic collision because the bullet is embedding itself into the block. So we have two different collisions here. And then they do give us some information, but they don't give us all of the information that we would need to find A and B like right away. So we need to first write down everything that we know, and then after that we can kind of make a game plan. Sorry if you can see my husband in the back. So we know that the bullet is 3.5 grams. So the mass, I'm going to call this MB. So my subscript for the bullet will be B, just to alleviate confusion because we have blocks 1 and 2. So I'll call those mass 1 and mass 2. Mass of the bullet is 3.5 grams. So that's 3.5 divided by 1,000, which is 0.003, right? Yeah, 0.0035 kilograms for that. And then they also tell us that the bullet passes through block 1, and the mass of block 1 is 1.2 kilograms. So M1 equals 1.2 kilograms, and then M2, it embeds itself in block 2, mass of 1.8 kilograms. So M2 equals 1.8 kilograms. And then it says the blocks end up with speeds v1 is equal to 6.3 meters per second, and v2 is equal to 1.4 meters per second. So it says first that the bullet is coming at those blocks that are at rest on a frictionless table. So this tells us, and I'm now going to kind of separate these into two different collisions. So I have collision number 1 and then collision number 2. So for collision number 1, V initial 1, so that will be the initial velocity of block 1, that is 0, because I know that the block 1 is first at rest on the table before the bullet comes into contact with it. It then says that it ends up with a speed of 0.63 meters per second. So that will be my V final 1. And then I also know the mass of the bullet, I know the mass of the block, but I don't know any information about the velocity of the bullet. So V initial bullet equals question mark, and V final bullet equals question mark. Okay, so there's not a lot of information that I know about these things. Now, the thing that I do know, though, is that the final velocity of the bullet as it leaves this block right here will be the initial velocity as it enters block 2. So V final bullet equals V initial bullet for collision 2. All right, so this right here will be V initial bullet for collision number 2. So if we find that for collision number 2, I can then use it in collision number 1 to find whatever else that I need to find. So what do we know about collision 2? Well, we know that the initial velocity of mass 2 is 0 because, again, the second block is at rest on the table before the bullet hits it. We also know that the final velocity of the block and bullet system when the bullet embeds itself into that block is 1.4 meters per second. And we know both of the masses. We also know that we want to find the initial velocity of the bullet. So from all this information and the fact that this is an inelastic collision, they stick together, right? That means the final velocity 2 will also be equal to the final velocity of the bullet. All right, so from this information, I can now find what I want to find. So for collision number 2, I get mb, so mass of the bullet, times initial velocity of the bullet, plus mass 2, mass of the block number 2, times initial velocity of block number 2, is equal to the final velocity of the system, because again, they're stuck together, times the quantity mb plus m2. So I know everything here except for that initial velocity of the bullet. I can now find that initial velocity of the bullet. So I know mass of the bullet is 0.0035 times initial velocity of the bullet, plus mass 2 times initial velocity of 2. Again, I know that the initial velocity of that block 2 is 0, so that whole term becomes 0. And then I get equal to the final velocity, which was 1.4 meters per second, times the quantity, mass of the bullet, 0.0035, plus mass of the second block, which was 1.8 kilograms. So here I get 1.8 plus 0.0035. I'm going to multiply that by 1.4 now. And so on the right-hand side, I have 2.5249, and then I'm going to divide both sides by 0.0035 in order to get the initial velocity of the bullet. So initial velocity of the bullet for collision number 2 is equal to 721.4 meters per second. So this is the answer to letter A, because it says, neglecting the material, blah, 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 find the speed of the bullet as it A, leaves that block number 1. So the speed of the bullet as it leaves block number 1 will be the same speed as it enters block number 2. So this is our answer to letter A. Now what we want to do, we know that this right here is also final velocity of the bullet for collision number 1. So now we can use that in our first collision. So for the first collision, we have mass of the bullet times initial velocity of the bullet plus mass of block 1 times the initial velocity of block 1 equals mass of the bullet times final velocity of the bullet plus mass of block 1 times final velocity of block 1. So here we know everything now except for the initial velocity of the bullet as it's going into block number 1. So that's what we're solving for here. So mass of the bullet is 0.0035 times initial velocity of the bullet, which is what we're solving for. Of course, initial velocity of block 1 is 0, so this whole term cancels out. And then I get equals mass of the bullet is 0.0035 times final velocity of the bullet, which is the initial velocity of the bullet for collision number 2, which we just found to be 721.4 meters per second, plus mass number 1, so mass of block number 1 was 1.2 kilograms, times final velocity of block number 1, which was 0.63 meters per second. So I'm going to do the right-hand side first. So I have the quantity 0.0035 times 721.4, close parentheses, plus, open parentheses, 1.2 times 0.63, close parentheses. I get 3.28 on the right-hand side. I'm now going to divide that by 0.0035 in order to get the initial velocity of the bullet, and I got 937.4 meters per second.